The substitution method, and we need to know what substitution means. Over to the right here it says substitution means we're going to replace something. So if you keep that in mind, you're replacing the y value. If you see this first equation, it's got a value given to us. We already know half our answer. We know y equals 10. We're going to take that value and we're going to replace y in the other equation with 10. So here's the steps. We'll go through them once together. You're going to choose the equation that has a variable by itself. So out of these two equations, this is the only one that has the y by itself. We're substituting its value into the other equation, and then we're going to do some solving. So the substitution part, sometimes it helps to draw this box and then to draw this arrow pointing to where you know it needs to go. After that, it's actually a pretty straightforward solving. What you need to do is you need to take this equation now that no longer has the y value in it, and you need to work on moving that 10 over. And then we know negative 2 minus 10 is negative 12, and you know that to get x all by itself, you're going to divide by 4. So if you do that correctly, you get your x value of negative 3. Now this equation was nice because we already knew the y value was 10. So that's how I know my POI, my point of intersection, is going to have an x value of negative 3 and a y value of 10. So always put your POIs in order with the x and then with the y. Now, we're not quite done with this question because we have to check. So these equations are just taken from the original equations in the problem. Y equals 10, 4x plus y equals negative 2. We know the y value to our answer was 10, so we just plug that in. 10 does equal 10, so this is a check mark. Over here we have to do a little math. 4x means 4 times this value of x. So we're doing another substitution. We're taking this value of negative 3 and we're putting it in place of x. We're going to do some multiplying here. So 4 times negative 3 we know is negative 12. And then we have to add the value of y. See how we substituted the value of y in? Negative 12 plus 10 is definitely negative 2. If your POI checks in both equations, you know you did everything correct up here, and this is the exact POI that you could find if we wanted to take the time to graph, which of course we don't in all situations. So if you open your note sheet, you're going to see the next example. Your next example, my screen up for you. Next example is a little different. You've got x equal to y plus 5. The top equation is much messier, so notice I pointed to this one. This is the equation that we're going to utilize to do our substitution. But we weren't lucky to just get a numerical value. We got this whole value, y plus 5, which is equal to x. We're going to take that whole value, put a box around it. We're going to grab it and we're going to substitute it into the other equation. So see where x is in this equation? We're going to take y plus 5 and we're going to substitute it for x. So this is what it looks like. This was originally 3x minus 4y equals 2, that top equation. Now, since we replaced or substituted the value of x, that's why this big 3y plus 5 is in there now. You know that this needs to get multiplied against 3. So we're going to go ahead and we're going to distribute. And when you distribute, you should get 3y plus 15. From here, we know that when we're solving equations, we will combine like terms. So by combining positive 3y with negative 4y, we get negative 1y. We still have a 15 that we're going to move to the other side. And then if we do our math right, 2 minus 15 gives you negative 13, and we still have this negative 1 to divide. So if everything is done correctly, you get a y value. The problem with this question is we still don't have an exact value for x. All we know is that x equals y plus 5. So here's what we do. You're going to take the equation that was given to us originally, x equals y plus 5. And remember that value of y that we just found? You're going to grab that value of y, since we know y is 13, and you're going to bring it all the way up here, and you're going to substitute y for its value 13. And then you'll notice we have really easy math to do here. All you have to add is 13 plus 5 to get your value of x. This means the point of intersection is 18 for the x value, 13 for the y value. Checking is just like the other question. You're going to take both equations. You're going to substitute x for 18, y for 13. You're going to do your math. We just did this one, so we know it works. This one takes a little more work because we have 3 times the value of x and then 4 times the value of 13. So if we again check our calculations, 54 minus 52 does give you 2, and it works. Next question. We have y equals 5x minus 8, and then we have kind of a messy equation below it. So always, again, pick the equation that has either y equals or x equals set alone. And then this value is what gets substituted in. This one's a bit challenging because we're substituting in and we have a subtraction sign in front of our y. So you might remember that this means we have negative 1 times y, which requires us to take negative 1 times that value of y that we just grabbed and substituted in. So we still have to multiply negative 1 times 5x, negative 1 times negative 8. Okay, if we do that correctly, you're looking at negative 5x, and remember, negative times a negative is a positive 8. Combining like terms, we get positive 1x. We get our 8 moved out of the way. And we eventually calculate to have this negative 3 minus 8 to give us negative 11. Again, that's half of our answer. Since we're looking for a point of intersection, we need to make sure that we not only have the value of x, but we have the value of y. So here's what we're going to do to get our value of y. That equation that we identified originally, we're going to take that same equation and we're going to substitute this time what we know is the value of x. X is negative 11, so you're going to grab that, you're going to bring it all the way up, draw an arrow on your note sheet, and you're going to plug it in. This means we have to do 5 times the value of x. If x is negative 11, we're doing 5 times negative 11, which is negative 55. And then we're subtracting 8 to get our answer for the y value. It's a very strange point of intersection this time. Negative 11 is the x value we got, and negative 63 is the y value that we got. We would need a very large piece of paper to find this point of intersection. If we were going to graph this thing on graph paper, you'd have to go all the way down to negative 63 and all the way over to negative 11 to find it. So luckily we have this new method called the substitution method that we can use. Example 4. This one's a little different because you notice that they both say y equals. So this would be a great one to graph if we really wanted to graph. But I wanted you to see how you can actually still solve this using substitution. Grab whichever one you want, bring it around, and plug it in for the y value in the other equation. So here I took negative 5x minus 17 and I put it on this side. And that was originally equal to negative x minus 1. So what we end up having here is an equation that has variables on both sides. We haven't looked at these in a while. So let's see if we remember to draw our locker and to look and see which variable is smaller. This one's smaller. So if we move that variable over, we're adding 5x. 5x plus this negative 1x gives us 4x's. And then it's just a matter of moving the 1 and dividing by 4. So there's your value of x. Started out a little differently this time because we didn't have parentheses to distribute, but we do have the ability, remember, to move x's to one side or the other depending on who's smallest. So we're halfway there. We need to pick an equation to substitute the value of x. So again, grab this, draw your arrow to remind you where it's going. You're going to dump it in this spot here where the x is, but you're going to keep this negative 1 outside. Remember, that means negative 1 times x. So we have to do negative 1 times negative 4, which is positive 4. And of course, 4 minus 1 is 3. So I did not write my sentence for my point of intersection. So let's do that. The point of intersection is negative 4, 3. And I'll let you do the check because I have trouble using the mouse to write on here. One more example, number 5. I'm going to switch over to use my pen on this screen. If I can get it to work. There we go. So example 5, we have a really messy equation on the top, 8x minus 2y equals negative 12. The one I want to focus on first is the bottom because we get this already given to us using the y equals. So that means we're going to take this whole chunk that y is equal to, and we're going to grab it and we're going to substitute it into the other equation where the y is. Remember, we're substituting. If we have a y equals, we're plugging in for y. So I'm just going to copy down the beginning parts of this equation. We have 8x minus 2. Remember, this means we're multiplying against the y value. Here's my y value that I'm substituting, and I still have an answer of negative 12 for that equation. So as always, when there's parentheses in your equation, you're going to distribute by multiplying. You're going to bring down your other terms, and then checking your signs to make sure you have plus 10x and plus 42. We're going to go ahead and combine like terms, and we're going to subtract. Negative 54 divides by 18, and it gives us negative 3. So if x is negative 3, remember we're halfway there. You're going to take your equation. I like this one to work with next. Grab it, bring it in. We know x is negative 3, so when you plug it in and you carefully do your multiplying first and then your subtraction, we have a POI of negative 3, negative 6. Now what you're going to do is you're going to take the second sheet that goes along with your notes, and I want you to try those questions. If you have difficulty, you can let me know, and I'll help you through them. Each one is going to practice the things that we talked about in your note sheet. And then when you get all finished, you're going to be taking your note sheet and you're going to be taping it into your notebook, page 67 and 68.